Hi everyone, thanks for taking the time to watch this video. I want to take just a brief moment to illustrate maybe a little bit more clearly to the kids and to you parents what I'm talking about when I'm asking your kids to show their work. And I was talking with a friend of mine yesterday, and there may be some confusion as to what is actually steps that you show in a problem, work, and computation. So I'm going to step through some illustrations here in a way that may make it more clear for your kids how to build the solid step-by-step foundation in algebra, that way in pre-algebra or even in beginning algebra, that will help them to progress more steadily and more solidly as they go ahead and continue on through their studies in higher level mathematics. But first I've got a dumb joke for you. What is black and white and has 16 wheels? It is a zebra on roller skates. So you see that picture right there, the zebra scooting along with his monkey friend on his back. So what I'm going to do is I've picked out some problems from a pre-algebra book, but it doesn't matter what this comes from, and all I'm illustrating now is how I want to show work when they're learning more the process of order of operations. And order of operations is what comes into play when you're deciding, okay, do I multiply first, do I divide first, do I add these things together, what do I do? And there's an acronym that the kids have been able to use to remind themselves what operations are they going to use first. I want to make sure that I'm within the screen. This is PEMDAS. Some of us learned it as Pretty Please My Dear Aunt Sally or Please Excuse My Dear Aunt Sally. But this is the order in which we prioritize numerical operations. First level of priority would be to work on anything that has the parentheses or exponents. That would be first level priority. And that orange doesn't work very well even though it's brand new. Second level of priority would be that we would work multiplication and division in order in our problem from left to right. And then finally, when we have taken care of order of operations that would include parentheses or exponents, parentheses would be things that they call symbols of inclusion. If you have brackets or braces or parentheses, you're going to work on those first from the inside out. Then finally, once you've dealt with multiplication and division, then you're going to deal with addition and subtraction in order left to right. So you have three steps that you're following. First, exponents and symbols of inclusion in order from left to right. Second, you have multiplication and division in order from left to right. Finally, you have addition and subtraction in order from left to right. So let me step through a couple of problems, illustrate to you what I mean by showing your work in computation. What I want the kids to do is first write out their problem. So here would be an example. We have problem number 1. We're going to copy it directly from the book. 16 plus, open bracket, the quantity, 21 minus 13, times 3, close bracket. And what we're going to do is we're going to show the steps over here on the step progressively down underneath the problem. And that's what I'm calling work. But I think the kids are calling work computation. So I think what I'm going to do to illustrate is I'm going to say, let's have the kids maybe draw a line to the right of the problems. And I'm going to go ahead and erase this PEMDAS here, because I'm going to expect them to remember that and you to know as well. So on the left side of the work, this is going to be steps that we're showing on the left side of their paper. Over here on the right side of the paper, this is where I want them to show their work, or you might call it computation. I think that's where there was a little bit of the confusion coming from. Now, I'm going to step up to the camera just for a minute so I can make certain the screenshot is showing everything that it needs to. What I want them to do is every single process that they're stepping through on this, show me one step, the next thing, the next thing, the next thing. Also, something that they need to know is when there's not an equal sign problem, you don't use an equal sign, because what we're doing here, these instructions would say evaluate. Evaluate means just come up with the number that this represents once we've done our addition, our subtraction, our multiplication. So what we have here, we have addition and subtraction, which are level 3. They're the very last things that you do. We have multiplication, which is a step that you do second. And then we have parentheses and brackets, both of which are symbols of inclusion. So our order of operations says we've got to get rid of all of those grouping symbols first. You work from the inside out. So you go into the inside, and you see that our inner group of parentheses here says 21 minus 13. Now, half of our kids are going to be able to look at that and say 21 minus 13 is 8. Some of them aren't. So I'm going to write things over here in the work column, or in the computation column, that a lot of people won't need to. When I say show your work, it doesn't mean that they have to write down every single 21 minus 13, but you could also call this, like maybe you grew up calling your paper, was called scratch paper by your teacher, work, or computation, or scratch. When I say show your work, I'm asking them, make sure you show me all of your steps. Off to the side is where you're going to do your addition, your subtraction, you're going to do your scratch paper, you're going to do your figuring. We're going to do this 21 minus 13 first. Let's say that I don't know that 21 minus 13 is 8. So over here, on the right-hand side of my paper, that's my scratch work. Now how am I going to show this step? We're going to replace one piece of information at a time. But every time that they're working, they have to write the entire problem. So this is what it's going to look like. 16 plus, we still have our bracket, but we're going to substitute in here 21 minus 13. We know now that that's equal to 8. So inside those parentheses, we have an 8. But we don't need to show the parentheses anymore because we've already done the operation that's inside it. What if your kids want to go ahead and still show that? Well, then let them show it. So you have 8 times 3. We close the bracket. This is what I'm calling work. They're showing their work. I don't want them to do all of these steps in their head. Now what are we going to do next? Well, we have brackets again. Inside it, what's it say? 8 times 3. 8 times 3 is a multiplication fact. There's no work that they can show. They just have to know this in their head. But maybe they want to write over here that 8 times 3 is 24. That's their scratch paper. It's just where they're doing their little scribbles because they're not allowed to use calculators, remember? Now what I'm going to do, I'm going to replace within these brackets 8 times 3 is 24. You don't need to keep those brackets there because you've already finished that computation. Now 16 plus 24 is 40. And then they're either going to circle that or they're going to square it to highlight that off. 16 plus 24 you can add in your head, it's 40. If they're making sure, 4 times 6 is 10, carry 1, 40. They're showing their work. What they've done here is they've showed me that they understand the process by which they step through the problem. This is what this problem should look like on their paper at this point in time. Over here, this work, this computation page, this is where they're just doing like the arithmetic part of it and making sure that they're checking their addition and subtraction. This stuff over here is voluntary. This stuff is what they have to show. And that's the differentiation here. Voluntary. A lot of our kids are at the point where they don't have to put any of this scratch over here. They already know and have practiced enough with their arithmetic. They can do this in their head. This, however, is mandatory. And this is what I mean showing work. I tell the kids, show your work. This is what I mean. And it's going to be on the first line of your paper, second line, third line, fourth line, then we skip a space. Skip this line. And then we're going to go ahead and do our next problem. And they say, man, it takes so much paper. My son said, Mom, it uses a lot of paper. It does, paper's cheap. Okay? If it is a problem, have your kids come ask me, I'll give them some paper. They need to be stepping through the process, and it's not that this is particularly a difficult problem for most of them. What they're training us to do is to think logically, to think in an orderly manner, and to take one step at a time, and to be methodical with what you're doing. Which is a good thing for me, because it doesn't come naturally for me to just be real structured and real focused, but this trains you. And we know that God's God of order, so it just patterns Him. And the next problem I want to show you is 12 plus 9 divided by 3. So they would write the problem, number 12 plus 9 divided by 3. There's no computation to show here because your kids are going to be able to do all of this in their head. But we look at this and we're looking for orders of operation. Parentheses are exponents. There aren't any. Multiplication or division. We have division. Addition or subtraction. We have addition right here. So our order of operation kicks in. This is what your kids are going to do that's wrong. And let me say wrong. They're going to look at this. If they're not really paying attention to the fact that we have order of operations, they're going to look at this and say, oh, 12 plus 9 is 21. And then they're going to say 21 divided by 3. This is showing their work. This is showing the step. They've first said 12 plus 9 is 21, and then they finished writing the problem. Then they say 21 divided by 3. No, that's my math fact. So that says 7. The computation here is correct. The answer is wrong because they didn't follow order of operations. Order of operations. It is true that 12 plus 9 is 21. It is true that 21 divided by 3 is 7, but that's not the rule that you have to follow when you're solving this. The kids will come back all the time and say, but Miss Betsy, da-da-da-da-da. I say, yes, but you have to do your order of operations. This is a real biggie for them. Real biggie for everyone. So now, how would we solve this correctly? Sure. You have 12 plus 9 divided by 3. It says do division first before you do addition or subtraction. So you still have to write the whole problem. 12 plus 9 divided by 3 is 3. 12 plus 3 is 15. This is the correct problem. I didn't do any work over here on the scratch side because I didn't need to. I knew how to do this simple arithmetic in my head. But you see this huge difference here. I didn't make any mistakes in my addition or in my division. What I made them, where I deliberately made the mistake here, is that I did things out of the proper order. Same thing in life, you get stuff out of order, get stuff out of the way that God intends for things to progress, and you end up with a mess instead of with the correct answer. Okay? Let me do another example for you. Actually, I'd like to do two more for you. Say that this is problem number 3. We have 15 times 4, quantity 15 times, whoops, they don't have those parentheses there. 15 times 4 minus 18 divided by 2. No parentheses, no grouping symbols, just a bunch of stuff run together. On the right-hand side of the page, let's just have them label at work. What do we have going on here? We have multiplication, we have subtraction, and we have division. How do you know what you're going to do first? Well, first you do parentheses and exponents. No parentheses or exponents. Then you do multiplication and division. Multiplication or division in order from left to right. Now, I'm going to go ahead and show you where I write every single little step as we go. Multiplication and division in order from left to right. Let's just do one operation at a time. 15 times 4 is 60. Perhaps your child doesn't know that. No problem at all. 15 times 4. 4 times 5 is 20. Carry 2 is 60. Or maybe they like to do something neat in their head and break it apart. 15 is the same as 4 times 10 plus 4 times 5, and then they can say, oh, there's 4 10s is 40, there's 4 5s is 20, 40 plus 20 is 60. Whatever. They're just doing some scratch work over here to come up with the fact that 15 times 4 is 60. Then you rewrite the entire problem. I'm not doing any of this computation over here underneath the steps. I'm not putting any equal signs in because there aren't any equal signs. Now, am I going to go ahead now and say 60 minus 18 is 42? Yes, that's true computation. No, that's not what they do next, but this is where they're going to get tripped up. So you say, oops. Order of operation says that I have to do parentheses and exponents, multiplication or division, and only then can I do subtraction. So you have 18 divided by 2. They can say that they want to do 18 divided by 2. Or they can write over here that they want to do 18 divided by 2. There isn't any work there. That's another one that they have to know, that 18 divided by 2 is 9. And you have 60 minus 9 is 51. Again, if they want to do that 60 minus 9 is 51, they're not sitting here doing 60 minus 9 is 51. They're showing this part over in their on their scratch paper. 60 minus 9, maybe they want to show still that they're borrowing. They have 51. This right here is what I'm talking about when I say, show me your work, kids. You have to process through each step. This over here is your scratch paper that they're working on. Hoping that this is making sense and it's a bit helpful to you. Now let me go through and do a very brief single example of evaluating an expression. And this isn't the easiest one, but all of you kids should be well past the, we've covered these a lot in class. And this says, simplify, then evaluate, for A is equal to 3, B is equal to 4. A is equal to 3, B is equal to 2. The bifocals are not working well this morning. B is equal to 4. And I have, let's say that this is problem number 4. 4A plus B plus 2A plus 3B plus 7A. What I told the kids is when you're copying a problem, go ahead and after you, especially if it's a longer one, string it out and make sure that you go back and check, make sure you copy it right. 4A plus B plus 2A plus 4A plus B plus 2A plus 3B plus 7A. And A is equal to 3 and B is equal to 4. Two things going on here. It says first, simplify, then evaluate. What does it mean when we say simplify? Well, simplify means if you have any like terms that you can collect together. Like terms are things that you can add, like if you have 3 apples plus 1 apple plus 2 bananas, you would simplify that description by saying you have 4 apples and 2 bananas. You can't combine the apples and bananas together without chopping them up and making fruit salad, then it's something different, okay? So what the apples and the bananas are what we call like terms. These are terms here, 4A plus B plus 2A plus 3B plus 7A. When you simplify, you group together the things that are like, just like you group your apples together, you group your bananas together, you group your pears. Or maybe you were like me when you're eating your bag of M&Ms when you grew up as a little kid, you'd separate it into all the different colors and then eat some from each one. And I know that's a little bit OCD, but you were still collecting like terms. Remember they had the blue M&Ms and light brown and dark brown. So what different terms do we have here? We have A's and we have B's. And for a term to be the same, if we have exponents, it has to be exactly the same letter. Has to be exactly the same variable. Just a little side thing here. If I had A squared, 4A squared plus 2A plus 7A, A squared is not the same as an A because the exponent's different. Now, what you do when you collect like terms is you add or subtract. Count how many numbers you have in front of it. We have a positive 4A, 2A, 7A, 4 plus 2 is 6, plus 7 is 13A, B plus 3B is 4B, 4, 5, 6, plus 7 is 13. There's not a number in front of the B, but if you have an apple, you don't have to say you've got 1 apple. You have an apple. You don't have to say you have 1 B. You know that you have 1 B. 1 plus 3 is 4. So this right here, we have simplified the expression. It can't be combined anymore. We have A's and B's. You can't mix them together. Now, then evaluate for A equal to 3, B equal to 4. What you have in algebra is the fact that this expression here can mean anything in the world depending on what number you want to let A be and what number you want to select for the variable B. Here we're saying that specifically A has to be equal to 3 and B has to be equal to 4. So what we're going to do is substitute. They have to show this substitution step. Substitute. For A, we're going to substitute in a 3. If I can remember to write 3 instead of A. Plus, B has a value of 4. They have to show substitution. Okay? When it's bumped up right against each other like this means 13 times 3 plus 4 times 4. 13 times 3 is 39, plus 4 times 4 is 16. Maybe at this point, say we haven't had a single bit of computation, nothing on a scratch paper, but we're still showing our work by going through the steps. Maybe they can't do 13 times 3 in their head. No shame there at all. Write it out. Maybe they still want to put that X there. Write it out when they're doing their computation. 3 times 3 is 9. 3 times 1 is 3. This is scratch. These are the steps that they're showing me. I don't want to see 13 times 3 over here in a step because you're not tracking down the orderly process of coming up with your answer. Now you have 39 plus 16, which is 55. You indicate that. You want to show 39 plus 16 over like this. 9 plus 6 is 15, carry 1, and you have 55. Show me the steps. Do your scratch work over on the right hand side. And I appreciate you taking the time to watch this. I appreciate those of you who've taken the time to sit there and watch it with your child to say, look, this is what steps are, this is what works are. I promise you that as they go through the discipline of writing step, 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 step down, they're cementing in their minds a better, just makes it easier as we move on through pre-algebra and algebra 2. Makes it easier for them to process their more involved problems. So I hope you all have a great day. I'll talk to you later.